I would argue that 23 is just about the hardest question for this 4.4 exercises. So in exercise 23, we have the scenario that a student theater charges $9.50 per ticket. The theater has already sold 70 tickets. Identify an inequality that represents how many more tickets, X, the theater needs to sell in order to earn at least $1,000. So I'm going to highlight my important information. The student theater charges $9.50 per ticket. They have already sold 70 tickets. Identify an inequality that represents how many more tickets, X. So X represents tickets. They must sell in order to earn at least $1,000. So that's our goal, is that we want at least $1,000. So I'm going to list that information out on the side. I'm charging $9.50 per ticket. The theater has already sold 70 tickets. And then X represents the number of tickets we still need to sell. Still need to be sold. And then lastly, we have a goal of getting at least $1,000. So that means we want the total money earned to either equal $1,000 or be greater than $1,000. We want at least $1,000. So that already makes that part right there is something that I can already begin to look to see which of the inequalities is going to make sense. But if we look at the inequalities, they all but one have the greater than or equal to 1,000 for the inequalities. So that already tells me that this last one doesn't make any sense, because we don't want our total money earned. I'm not saying that's the right equation for our total money earned, but we don't want it to be less than $1,000. We want it to be greater than $1,000 because we want to make at least 1,000. So that's the minimum amount that we want to make. So that already tells me that I can remove that inequality. That's not going to work. Now I need to figure out here, how am I going to use all this information to create an inequality? Well, I want to make at least $1,000. Here's my goal of $1,000. I already have some money. I already have 70 tickets worth of money, but I'm not going to put here that I have 70, because I don't have $70. I have 70 tickets worth of dollars. So if I wanted to figure out how much money I already have started with, that this here and this that I'm shading right here, that's how much we still have to make. If I want to figure out how much money I started with, then I need to take those 70 tickets and multiply it by the $9.50 that's being charged per ticket. And doing so, that's how I'll figure out how much money I started with. And then to determine how much money I need to make to reach my $1,000 goal, that I'm going to also multiply by $9.50 per ticket, because the ticket price isn't changing. Still $9.50 per ticket, but I need to determine how many tickets do I need to sell. And so I'm going to multiply that ticket price by X, the number of tickets that I still need to be sold. And so to determine my total money earned, which is what I want here, I want my total money earned to be greater than or equal to 1,000, then I would take the money that I have now and add it to the money that I still need to make. And so let me go ahead and make some space here for myself. I'm just going to minimize this a little bit. So like I said, if I want to find my total money earned, then that means I need to take the money that I have already started with in the scenario and add it to the money that I still need to make, and that's going to give me my total money earned, which I need to be greater than or equal to 1,000. So I'm going to put that here. I'm going to do $9.50 times 70 tickets. I'm not going to put the tickets in there. That's going to be added to the $9.50 times X, which is the number of tickets I still need to sell. And I want that to be greater than or equal to 1,000 because I want to make at least $1,000. So I either want to make $1,000 or greater than $1,000. Now the thing to notice here, and I'm going to change this multiplication sign to a little dot. The thing to notice here is that we have 950 in both of them, in both of our expressions here that we're adding together. I'm going to rearrange this a little bit, and then maybe you'll see something kind of familiar here if I rearrange these. If I can rearrange them. You might notice when we arrange this that this actually looks like one of our factoring problems. We have 950 in both of these expressions, and so we can actually factor out $9.50 from that left side of the expression. And when I factor out 950, then what I'm left over with is I'm going to take away that 950. That's going to turn into a 1. It's going to leave me with X. And then when I take that 950 times 70, when I take that away, that's going to leave me with a plus, because of this plus sign here. 70 is going to be greater than or equal to $1,000. That's going to leave me with this inequality, because then the reason that I can factor this out is because if I would use the distributive property to put it back together, I'd be taking 950, multiplying it by X, just like it is being done here. Then I'd be taking 950 and multiplying it by the 70 tickets we've already sold, which is being done here. And so this is the same expression here, but now it's in a factored form. And while it's in this factored form, you can see that it actually looks exactly like this one, and that's because that's the inequality that represents this situation. And except for they don't want it as... The tricky part about this question is that they're not asking you to actually solve out how much money you started with, because, like I said, we would just multiply 70 times 950, which ends up being something around almost $700 or so. But they don't want you to do that. They want you to set up the equation and then actually factor it out. So it's a tricky question. It's something we can work through. We have the skills to do it, but this is probably your first time being introduced to a question like that, where they're asking you to kind of work backwards almost. And so now you see though that if you're multiplying both of these values by 950, then technically these values that they're being multiplied, you can just add those together as a quantity, this parentheses quantity here, and multiply by both of them by the 950, because when you do the distributive property, you get that same equation back, that same expression back. All right, now that we've reasoned through that, the next thing that we're being asked is, just like we're asked in all our questions, that we need to find the solution of that inequality. Now, when solving for x here, we're going to do this one together. When solving for x here, I'm going to move everything over here. When solving for x in this inequality, you can either do the distributive property and turn these numbers into some larger numbers. You'd have 950x plus 70 times 950. Or what you can also do is something I've talked about in some of the past videos, is that you can get rid of that 950. You can cancel that out first by dividing both sides by that number, since it's outside of the parentheses. So we can divide both sides by $9.50. And that's going to leave me on the left side with x plus 70 is greater than or equal to, and then we need to determine what is 1,000 divided by 950. $9.50. So I'm going to move this decimal over 2 spots, which means I need to move this decimal over 2 spots. I'm going to fill this in with 2 zeros, and then now I've got a even larger number where 950 is being divided into 100,000. So big number here, that's why we're doing it together. Well, the first part's pretty easy. It's not going to go into 1, it's not going to go into 0, I'm not going to go into 10 or 100, but it will go into 1,000 one time with a remainder of 50. I'm going to drop down this 0, and it's not going to go into 500, so I'm just going to bring that 0 up here, drop down the next 0. It will go into 5,000 about 5 times. And I know this because 950 is almost 1,000. It's just 50 from being away, 50 away from being 1,000, and 1,000 times 5 is 5,000. So it's probably somewhere around 5. 950 times 5 is 4,750. Remainder of 250. And I'm not going to add a decimal. I'm going to leave this as a fraction. So my whole number here is going to be 105. And then my fraction is going to be 250 over 950, which both can simplify by 10. So that'll be 295 divided by 95. And then both can be divided by 5. It'll be 5 over 19. So 105 and then 5/19. And then still to solve for x, we're still not done yet. We need to subtract 70 from both sides. Subtracting 70 from both sides leaves me with x is greater than or equal to 35 and 5/19. So I hope you noticed there that the 5/19 is still the same. You're taking 105 wholes and 5/19 and then subtracting 70 wholes. So you're really only subtracting the whole numbers here. 105 minus 70 is 35. 5/19 is still there. And so what this means, what this solution means, is that we have to sell at least 35 and 5/19 ticket. But that doesn't really make sense. We're not going to sell 35 and 5/19 of a ticket. We're going to need to sell a whole 36 tickets, because selling 35 tickets isn't enough to make our goal. We need to either sell 35 and 5/19, so a little bit bigger than 35, or greater than that. And because we're not going to sell part of a ticket, we have to sell a full ticket. Then if we round up, the next whole number is 36. So we're going to need to sell at least 36 more tickets in order to reach our $1,000 goal. Part B, the theater increases the ticket price by $1 without solving an inequality, so this is just mental work. Describe how this affects the total number of tickets needed to earn at least $1,000. Because each ticket costs $1 more, blah, tickets will be needed for the theater to earn $1,000. So if you're charging more, that probably means you're going to make more money per ticket, and so you're probably going to need to sell less tickets in order to reach our $1,000 goal, since we're making more money for every ticket that we sell.